How does soap work, and what is a surfactant? As I said in my speech, is clean safe? Water is pretty miraculous because it dissolves almost everything we consider dirt. Then why don't we just clean ourselves, our clothes, our house with just water? Because it doesn't do a good job cleaning grease. That's why most of us would not consider a shower complete without spreading some cleansing suds all over your body and rinsing them off. Or our clothes are house cleaned without using detergent. But how do soaps and cleansers work? First, let's determine what we are cleaning. Think of your skin covered with your natural body oils. Almost instantly, dirty dust lands on it and sticks to the oils. That dirty dust has germs on it. Now the germs have a lovely place to grow. Yum! Your body oil also gets on your clothes and attracts germs. Those germs are what makes your clothes stink. Your dirty dishes have food oils that attract germy dust, and so does everything in your house. Of course, we want to eliminate the germs, and what better way than to get rid of the oily grease that holds the germs? As I said before, water is a polar molecule that dissolves other polar molecules like salts and sugars. But oils are not polar molecules. Herein lies our problem. How do we get water to attach to nonpolar grease? Enter the magic of soap. And that overly complicated word coined in 1950, surfactant, surface active agents. A surfactant reduces the surface tension of the water. Let me remind you of what is meant by surface tension. You know when you see some water on a counter and it looks like a roundish bubble? It's surface tension that holds it together to make it look that way. It's really that the magnetically charged water molecules are good at sticking to each other if there's nothing else to bother them. Soap breaks the polar bonds that keep the water holding together in a bubble. Let's watch this at work.
Into one big one, or we can collapse them if we dip our toothpick in soap and then touch them.
Did you see how quickly the surface tension of the blue water drop was broken when he touched it with a toothpick that had been stuck in water? But how exactly does soap do that? And what does that have to do with cleaning? Somehow we need to make water grab the germy grease like it grabs salts and sugars. That's not exactly possible, but soap does the next best thing. It becomes a link between the water and the oil. One end holds onto the water molecule, and the other soap end grabs a glob of germy grease. Soap is a molecule that has a water-loving end that attaches itself to water. The other end hates water but loves grease. Let's picture the soap molecule like a lollipop, with the lollipop end loving water, and the stick end hating water but loving grease. Then, if we put a bunch of these soap molecules together, we get a ball-like sphere called a micelle. The outer part of the micelle ball loves water and attaches itself to a water molecule. The inner part of the micelle ball surrounds a piece of germ-laden grease, which has been freed from whatever surface it was attached to. Your body, your clothes, or a dirty dish. When you rinse off the water, all the micelles attached to the water go down the drain with it. This is what the micelles caused by the magic of soap actually look like. A surfactant such as soap or detergent enables water to grab grease so it can be rinsed away. That's how soap works. But in today's world, very few of us use soap. Instead, we use petroleum-based cleansers. This begs the question, with all of our current knowledge, is using cleansers the best way to clean? To explore this question, join me in my next speech, Cleaning Bacteria.